And here we go, okay? All right, so today we want to start talking about extreme values over given intervals and specifically parabola shapes. But just a little bit of an introduction. These points on the graph are extremely interesting to us. This is what we call a local maximum. And a local maximum is important in a graph. It isn't the largest spot on the entire graph. You can see that there's spots up here that are bigger, but within this general area, it is the largest because we like to maximize things. Okay, for example, is there anybody here who does not like money? No. Okay, everybody here likes money. Good for you. What if you wanted to, say, maximize profit? Does that sound like an interesting thing to do? Yes, and so those of you who will become business majors and get a major in economics, there is calculus-based economics by which you will find out how to maximize profit or to minimize cost. There's applications outside of business as well, and we're going to get to these applications. You're going to see real-life applications of this class. This is what we would call a local minimum. And there's all sorts of ways in which you can apply the thing of minimize. I gave you minimize cost, but I'll just show you one I think is really cool. Minimize viscosity. Minimize viscosity. Viscosity is a measurement for friction of blood flow, okay? Friction of flow of liquids. Okay, so my calculus teacher when I was in college, he actually worked at the Mayo Clinic before he was working with us. And he said that he worked at the Mayo Clinic and he would sit in an office and wait for people to come and ask him questions to solve problems. And one day a doctor came to him and said, I have a patient who has a clogged artery. Would everybody agree that that's a bad thing? What happens as a result of a clogged artery? Heart attack. Basically, the interior blood design of your body explodes. Okay, that's what happens. So what you have to do is there are a few treatments, but one would be to put in a what we call a bypass. And a bypass is literally where you take another piece of artery and stretch it from one side to the other so that the blood can go in a different direction. Okay. Now the problem is that when the blood turns direction like that, you end up with some friction on this joint, friction overall, and you want things to move real smoothly through your system. So the doctor came to him and said, at what angle should I place this branch, angle theta, so that I minimize the viscosity of the blood flow? You would like that if the doctor asked that question, right? Or do you want the doctor who says, I just put them all in at 45 degrees? You want the doctor who knows that answer, right? The doctor didn't know the answer. The doctor went to the mathematician. The mathematician calculated it, and in that situation, it was 71 degrees. It actually depends on the radius of this one and the radius of this one as you make that determination. But mathematicians figure out incredibly complicated ideas, and they are often based around this idea of minimum and maximum. Minimum and maximum. So let's look at the basic type of equations that involve minimums and maximums, and those would be the things called parabolas. Parabola looks like this. And notice that the parabola has a maximum location. That maximum is what we call, anybody know it starts with a V? Vertex. It is the vertex. Very good. The vertex has a formula to find its x location. The vertex has a formula to find the x location. Anybody know the formula? Hint, it involves A and B. Be my first class who can remember it. Come on. You're the best of the best. You know it, you just don't know you know it. I'll show you how you already know it. What's the quadratic formula? You remember that, right? What's quadratic formula? A B plus or minus. Okay, so people know that, right? Well, the vertex formula is right in there. Okay, it's right there. It's negative b divided by 2a. because that's what it is. The x-intercepts, they center around the vertex, and it's a certain amount this way, and it's a certain amount that way. It's plus and it's minus from your negative b divided by 2a. So you have negative b divided by 2a is going to be the x value of the vertex. The way you get the y values is simply just plug it back in. Now, notice that this spot right here, that is the y-intercept, okay? In order to find the y-intercept, what value do you plug in for x? What does x become if you're finding the y? X becomes 0. What value do you get if you plug in 0 for x? You get c. The y-intercept happens at whatever the c value is, okay? And then we call these the x-intercepts right here. And those x-intercepts, we're going to talk about how to find those in a second. So flip it over to the other side. We're simply going to do 2 problems for your lesson. 2 problems. And we are going to list these characteristics. We are going to list the direction. We are going to list the vertex. We're going to have the axis of symmetry. We're going to have the y-intercept. And we're going to have the x-intercept. So those are the 5 pieces that we're going to find with this parabola. Give you a second to write those down. What's the direction? Why? Yeah, 2x squared is positive, goes up. The y-intercept is easy to determine. What's the y-intercept in this situation? Negative 8. It's just whatever constant's on the end. Boom. Got those 2 things. Knock them out. Those are on the test. We got problems, folks. Okay? All right. So I want to find the vertex. I take negative b and I divide it by 2a. All right? What is negative b in this situation? It is 0. Because there is no x term. B is the coefficient in front of x. Divided by twice the a value, or 4. And so you get 0. So the x value of the vertex is 0. X value of the vertex is 0. How do you figure out the y value of the vertex? You plug it in. If we plug in 0, what is the output? Negative 8. All right. I have a vertex. Is that going to be the lowest point on the graph or the highest point on the graph? The lowest point on the graph, because its direction is up. So I'm going to make a sketch here. I'm going to do a 8 by 8 graph. Brought in some firewood last night. Keep the house warm when I get home. Don't want the firewood wet, right? Hannah doesn't believe I actually burn wood in the house. Do I not look like a tough guy?
No, you remember?
Do you think that I use a splitter to split all my firewood, or do you think I do it by hand with an axe? What do you think? Oh, yeah. Yep. Because I'm tough, Adrian. I'm tough.
Yeah, remember your farm tough.
Yeah, I'm country tough.
Your country.
I'm country tough. Remember that. All right, like Royce Lewis. Let's go Twins. Sad story. All right. So now I got to find the axis of symmetry. I'm going to plot that vertex. The vertex is located at 0, negative 8, right there. Okay. Same place as the y-intercept. The axis of symmetry is an imaginary line that divides the parabola in half. So I'm going to draw this dashed line to represent the axis of symmetry. Vertical line or horizontal line? Does a vertical line have an equation of x equals or y equals? X equals. What x value does it go through? 0. The axis of symmetry will always be x equals the x value of your vertex every single time. If you just write 0, I take a half a point off because it's not a number. It's an equation for a line. X equals 0 is an equation for a line. Don't just write 0. I'll take a half a point off. So the last thing I need to find is the x-intercept. In order to find the x-intercept, we plug in what for y? 0. And you get 0 is equal to 2x squared minus 8. Isn't 0 just a great number? I mean, it really is. We use it all the time in mathematics. It's a beautiful piece. And then to solve this, you have 2 options. We either factor it or we use the quadratic formula. Does that factor? Yeah. Factor what? How you factor this? First step is take out
Take out 2.
take out the dos, which is Spanish for 2. That factor is 2x minus 2, x plus 2. So my x-intercepts are plus or minus dos. How do you say plus or minus in Spanish? Plus or minus?
Más y menos. Minus is menos.
Menos? What's plus?
Más.
Mas? That's the same as bad.
No, it's
No,
mal.
bad is mal.
Mal. Oh,
M-A-L.
okay. I got it. Muy mal. Muy mal. There we go. Okay, all right. I'm learning. Yeah, I'm learning. All right, so I'm going to plot the plus or minus 2. They should sit equidistant from the axis of symmetry. And I draw my parabola, and it gives that kind of sharp shape because it's stretched by a factor of 2. We talked about that in this past unit. And then we've got our beautiful looking parabola. Look good? This is kind of coming back a little bit. Remember doing this in Algebra 2 and Algebra 1 with Miss Kruger. She loves parabolas. She talks all about it, okay? So let's try one that's a little bit more challenging. We'll do this one. It'll be done. I do the same things. I do direction. I do vertex. I do axis of symmetry. I do the y-intercept. And I do the x-intercept. Okay? That's what I've got. So I did the first one. You guys help me out with the second one. Where do you start?
Direction.
Yeah, direction. Up or down?
Down.
Down. How come?
Negative.
The term in front of x squared is negative. Goes down. Y-intercept? 3. Okay, we've got 2 quality characteristics so far. That's good. Now we need to determine the vertex. What is negative b? Divided by what? 2 times negative 1/4. What's 2 times negative 1/4?
1/2.
Negative 1/2? Oh boy, I don't know how to divide by fractions. Just multiply by the reciprocal. Sounds like Evie's ready to go. 6 times negative 2 is negative 12. Way to go, Dorothy. All right, what do you do to find the y value? Well, again, take out your calculator. Take out your calculator. Calculator. Okay. So I often get people who get the y value of the vertex incorrect because they're not plugging it into their calculator correctly. I want to make sure you can all do this. I type in negative 1 divided by 4 because it's a negative 1/4. And then instead of an x, I put parentheses, negative 12. So notice I have, sorry, this doesn't operate as well as I would like it to. Okay, that's negative 1/4 times x squared, where I plug in negative 12 for x. Notice I just replaced the x with parentheses. Everybody okay with that? And is it plus or minus? I can't remember. Minus 6x, so minus 6 times parentheses, negative 12. Hey, come on. And then I've got a plus 3 on the end. I press enter on that, and I've got 39. 39 is my result. So I've got negative 12, I got positive 39. Is that going to be the top of the parabola or the bottom? Top, because it's upside down. So I'm going to mark off 20, 30, 40. I'm going to go by tens. You can do what you want. If you want to go by ones and have 40 tick marks, that's up to you. Everybody can make choices, even if they're dumb sometimes. Okay. And I'm going to plot that negative 12, positive 39. So I'm going to estimate. Your graph doesn't have to be perfect, and graphing is not a punishment. Some of you might be like, why do we have to graph? It takes forever. This is so that you can confirm your answer. This is to help make sure you don't get problems wrong on the test. So I plotted that axis of symmetry through my vertex. What is the equation for the axis of symmetry? Good. It's always x equals the x value of your vertex, 100% of the time. So I've got everything. I got my y-intercept of positive 3. I can even plot that positive 3 on the y-axis. And because you have your axis of symmetry, you could just flip a point over that to get over, over here. So you know the direction of it, you know the general shape. The last thing I need is I just need the two x-intercepts. In order to find x-intercepts, you plug in what for y? 0. Notice the equation. 0 is equal to negative 1/4 x squared minus 6x plus 3. I don't really like the look of that. Do you want to try to factor that? So what are you going to have to use? Quadratic formula. I don't want to use the 1/4 either, though. Times it by negative 4. Since you got 0 on the other side, just multiply everything by negative 4. Because 0 times negative 4 is 0, and then negative 1/4 times negative 4 is 1. Negative 4 times negative 6, I get positive 24x, and then negative 4 times 3 is negative 12. So now it's in a much more usable form. Just be careful, folks. You can't multiply it by negative 4 at the beginning, because then you would be multiplying y by negative 4, and then you would have a negative 4y. You don't want that. But here you multiply 0 by negative 4, and it still stays 0. So that's a good deal. All right. I still don't think that factors, does it? So quadratic formula, away we go, but at least we don't have a fraction. I'm going to have negative b, or negative 24, plus or minus the square root of, everybody's memorized their squareds here. What's 24 squared? Want to take a guess? Benji?
Yeah, I'll guess her guess.
Dorothy says 576. Away she goes. Okay, got 576 minus 4 times 1 times negative 12. Or, yeah, divided by twice the a value. So the part underneath the square root sign is called the discriminant. It's called the discriminant because it tells us whether we're going to have real solutions or imaginary solutions and how many solutions. What is 576 minus 4 times 1 times negative 12? 624 divided by 2. Now, on the test and in your homework, you need to write this in simplest radical form. I gave you a really tough one. You guys are going to have easy ones like square root of 20 and stuff like that. But 624, is there a perfect square that divides evenly into 624? 4 goes in, so if you take that 624, and you divide it by 4, so, Evie's like, hey, I'm going to take a guess here. Well, if it divides 4 once, maybe it divides it again. Hey, if it's divisible by 4 twice, that means it's divisible by 16. 4 times 4 is 16. So if it divides by 4 twice, it divides by 16. That's good. So it looks like I would have the square root of 16 times the square root of 39. That's what I've got. Square root of 16 times the square root of 39. So we've got negative 12 plus or minus the square root of 16, which is 4, times the root of 39, all over 2. We're almost done here. Those are all divisible by what? Dos, which is Spanish for 2. So I get negative.
You already?
Yeah, you already did that.
Oh, it's the 24, right?
Yeah.
Sorry about that. I thought there was something was wrong there. So I got negative 12 plus or minus 2 roots of 39. So on the test, I want to see simplest radical form, and then I want to see decimals as well. Why do you think I want decimals? So then I can actually plot the graph. So I go to my calculator, and you just type it in. Negative 12. Why do you not? Negative 12 plus 2 roots of 39. That's going to be 1 x-intercept. The other one is going to be negative 12 minus 2 roots of 39. And there we get negative 24.49. So positive 0.49 and negative 24.49. 0.49 and negative 24.49. Notice that when I plot these on the graph, they fit with the rest of the description of the graph. Looks like it's going to go right down through those blue points. And I make it a nice, pretty graph. So I tried to do a pretty easy one for you guys. I tried to do one that's more challenging. Your problems in your assignment are going to be on the easier side. I really wouldn't wait until 3 weeks to do this assignment. You guys get an extra day compared to third hour. Third hour doesn't get class tomorrow because we have the distinguished alumni speeches. So they're going to be doing that. So tomorrow would be a good time to maybe knock this assignment out. But I would do this assignment either Friday, Saturday, Sunday, or Monday. But Tuesday, you want to be working on that study guide to get ready to go.